The last section that is on this video is polynomials. And so once we get things into factored form or in expanded form, it is something that has a degree of 2 or a degree of 3, and the degree is representing the largest exponent of that polynomial. So all together this has an exponent of 1, an exponent of 2, an exponent of 3, and so all together 1 plus 2 plus 3 is going to give me an exponent of 6, and so that is the largest exponent for this function here, and that will be 6. This one, once everything has been expanded, the largest exponent on this one would be 3. And so anytime your degree is 2 or 3 or 4 or more, that is usually what we're talking about when we say polynomial. And so we're looking at the degrees of the polynomials. We're also looking at the factors of the polynomials so that we can find the zeros. And so speaking of zeros, each zero has a multiplicity, like we saw on that last problem. So x to the first, that has a multiplicity of 1. X minus 2 squared has a multiplicity of 2. X plus 5 cubed has a multiplicity of 3. So the zero for this factor, if we set x equal to 0, is 0. We set x minus 2 equal to 0, move the 2 over, that gives us x equals 2 as an x-intercept, and x plus 5, when we move that over, equals 0, that would be x equals negative 5. So the 0 at 0 has a multiplicity of 1, the 0 at 2 has a multiplicity of 2, and the 0 at negative 5 has a multiplicity of 3. And so thinking about our degrees, if it has an odd degree, so if it has, on this last question here, this has a degree of 3, that's an odd number. It is going to behave like an odd function. If the degree is even, then it's going to behave like an even function at infinity. And so here we have odd end behavior, and we have positive and odd. We also have negative and odd. We also have positive even and negative even. So odd functions behave like linear, where it is increasing, it's positive, so it starts low and ends high. Negative linear functions are decreasing, they are starting high or positive and ending at negative infinity. Positive even is a U-shaped graph, like a quadratic function, so it starts high and ends high, but when it's negative, it is decreasing the whole time, so or the end behavior is decreasing, so negative infinity to negative infinity. And so that's what our end behavior will look like. And then for the multiplicities, the difference on our graph, when we're graphing them, a multiplicity of 1 looks like a linear function. So if we zoom in just on this point where it crosses the x-axis, that is going through there in a linear way. The one at 4 is a multiplicity of 2, aka a quadratic. So if we zoom in on this point here, it's bouncing off the x-axis like a quadratic function. And then if we zoom in on this one, it has a multiplicity of 3, and so it looks cubic. And so it kind of wobbles through. Instead of going straight through like this one did, it kind of wobbles through like your cubic function does normally. So this would be a negative function. This would have an exponent of 1, an exponent of 2, and an exponent of 3. And so all together the degree is 6, which is even. And so it's even and negative. And then I have an x-intercept at 0, an x-intercept at negative 3, and an x-intercept at positive 4. So when I'm graphing these, and this one would have a multiplicity of 1, this has a multiplicity of 2, and this one has a multiplicity of 3. So at 0, I have a point. At 2, 3, 4, I have a point. At 1, 2, 3, I have a point. And so I'm starting down here, and I'm ending down here. So I'm going to start here and bounce off this point. At 0, it's a multiplicity of 1, so I'm going to go straight through like a linear function. And then at 4, it's a cubic, and so I'm going to wobble through there, kind of wobbles through, and those are going down forever. So the reason we're identifying all of these things is so that we can create the picture that goes along with it. And that gets us through to the end of first 9 weeks.